Okay, so to continue on from our previous lesson and doing the word problem, we are now going to solve two exponential equations and find their solution. Okay, and we sort of did this in the previous word problem, but in the previous word problem, we had an exponential function, remember the value of the car, and then we had a linear function, which was y equals 20,000, right? So we had two equations there that we found the solution of. We saw when they intersected on the graph. The difference here now is we're going to have actually just two exponential functions, not an exponential and a linear, but just two exponential functions. And once again, their solution will be their point of intersection. So if let's say you had two exponential functions, one like this and then one like this, okay? Think of what the point of intersection is and why it's the solution. It is the only point that exists on both curves in a common way, right? So it exists on both curves and they can only intersect at one point. So that means there's only one point that's common between the two of them. That is what's known as their solution. So we can do this algebraically, which we'll do in the next lesson, or you can do this using graphing technology. So for this lesson, we'll do it using Desmos. All right, so we have two equations. We're going to find their solution, or the point of intersection. Okay, so, and then, also, I'm going to show you how to check your answer as well. All right, so how you can go back and make sure that you did, in fact, find the point of intersection. Okay, so essentially what we're doing here is just plotting each graph individually and then finding the right zoom setting so that we can see where the point of intersection is, finding the right scale. All right, so y equals 16 to the power of, okay, and then another equation, y equals 8 to the power of 3x. So you can see that I can't really see each curve right now, right? I don't have the proper zoom settings. So let's see here. I can keep zooming in on my screen until I think I can see the point of intersection. And actually, you can see that if I just tap on the curves themselves, the point of intersection should get highlighted. All right, did you see that? So I'm just tapping remotely close to the point of intersection and it's snapping right to it. I wasn't actually hitting the point of intersection itself, okay? Know that you can use the minus and plus button to zoom in and out here, okay? So you can do that fairly quickly. So again, I'm just touching my finger somewhere close where I think the point of intersection is, and Desmos knows that I'm looking for it, and so it automatically snaps to it. And so the point of intersection, or the solution here, is 0, 1. Okay? So just write solution 0, 1. Let's analyze what that means. That for each equation, remember this point exists on both curves. If we sub in a 0, we should get 1 for both. Okay? So let's try it. So I'll do like a left side and a right side check. I should get, for 16 to the 2x, when I sub in a 0, I should get 16 to the power of 0. Anything to the power of 0 is 1. Okay? Same thing here. 8 to the power of 3x, sub in a 0. Anything to the power of 0 is 1. And so you can see that 0, 1 satisfies both of the equations, meaning that that point exists on both curves. Okay, let's do one a little bit more challenging. Let's go over to C. I want to do C because Desmos, see how the exponent is like an expression 2x minus 4 and 2 minus x? Desmos handles this in a certain way that I need to make sure that you can see. All right, so I'm going to plot each of these equations, okay? And you'll see how I'm going to type these into Desmos. Okay, go back home. I have y equals 25 to the power of. Now, because it's an expression 2 minus x, I have to put it in brackets. It's the only way this works in Desmos. Okay, and then close your bracket. It will not work if I don't put those brackets in as my exponents, into my exponents. Okay. Then my other equation is y equals 125 to the power of bracket 2x minus 4, close bracket. Okay, so there you go. Those are the two curves. And what's great is that that point of intersection is already highlighted for me. I can just click on it and I see that the POI is 2, 1. That is my solution that exists on both curves. So come here, solution, two, 1. Do a check, left side of each equation. So 25 to the power of 2 minus, now what's my x value? I'm going to replace my x with what? Correct, 2, right? Because my x value for my solution is 2. You get 25 to the power of 0, which is 1. Good, so it satisfies the left equation, right? I get 2, 1 as my, when I input 2, I get an output of 1. Let's try that here. 125 times 2 times, let me just, 2 times 0 times 2, sorry, minus 4. And those are exponents, right? This whole thing here is an exponent. So it equals 125 to the power of 2 times 2, which is 4, minus 4, 0. Once again, anything to the power of 0 is 1. So again, this checks out. When I put an input of 2 for x, I get an output of 1 for y, which means that I have the proper solution here. Okay? They're equal. And notice that that solution exists for both curves. All right? So that's all I'll do as part of this lesson. I think that's enough examples. The trick is just properly inputting this into Desmos and then finding your point of intersection, okay? And then checking your answer. You always have to check your answer. It will help you understand the next lesson when we solve this algebraically, okay? So it should help you with that when you check your answer. All right, so you can go ahead and finish all the examples on this sheet here.